The discussion around vehicle range did not begin as a stylistic idea or an attempt to make a marketing headline, but as a direct response to fundamental limitations of how far a practical electric vehicle must travel using only the energy it stores. The earliest conversation circled around identifying the absolute minimum range that still feels meaningful to an average driver. That figure eventually settled around 250 miles, not because it sounded impressive, but because anything below that distance risked falling into the category of short-range city commuters that many people consider restrictive. From there, the ambition grew naturally. A mid-500-mile benchmark emerged as the middle ground between ambition and realism, representing a space where the efficiency of the overall platform could shine while staying within achievable engineering constraints. The 1,000-mile concept entered the conversation almost jokingly, but it quickly transformed into a serious design challenge when calculations proved it feasible within the laws of physics, rather than outside them. This high-end target became a proof point, showing that when a platform consumes dramatically less energy per mile than conventional vehicles, unheard-of distances suddenly become possible. Once these targets were identified, the design implications became clearer. Instead of creating different bodies for different ranges, the approach was to develop a single optimized envelope that could accommodate multiple energy capacities without compromising the essential aerodynamic profile. The structure, proportions, and overall packaging had to remain constant, allowing the battery system to scale internally. Weight differences between energy variants naturally follow, but they are absorbed within the overall efficiency philosophy rather than breaking it. The greatest challenge was ensuring the largest battery configuration used for the highest range version could physically fit within the same form factor without forcing the vehicle to grow or to change shape in a way that would destroy its aerodynamic advantage. This engineering design cooperation became even more sophisticated once computational fluid dynamics became the central method of validating airflow behavior. Where earlier generations of designers had to wait for scale models carved in clay or foam to be tested inside costly wind tunnels, now countless variations could be run through digital simulations in a fraction of the time. The result was not just faster iterations, but a deeper exploration of design possibilities, because it allowed refinement down to minute contours, surface transitions, and even unconventional shapes that traditional modeling might never have suggested. Artificial intelligence tools introduced another layer of exploration, generating shapes that were sometimes visually awkward, yet mathematically promising. Instead of copying those shapes outright, the design team treated them as provocations, ideas pointing in directions that human intuition might overlook. Each potential improvement flowed back into the CFD loop, creating a cycle of suggestion, refinement, validation, and comparison until a consistent aerodynamic advantage emerged. Despite this deeply technical process, human comfort and usability were never pushed aside. Aerodynamics alone would lead to shapes that physically restrict many drivers, making the interior cramped or the seating posture uncomfortable. Because a vehicle must serve human beings rather than wind tunnel numbers, compromises were made where necessary. The team refused to shrink essential interior volume even when simulations showed that a slimmer or lower form could offer incremental improvements. The overriding belief was that efficiency only matters when the product remains enjoyable and practical to use. The charging interface decision followed the same philosophy of prioritizing simplicity and human experience. Instead of selecting a bulky or complicated connector solely because it was common in certain regulatory frameworks, the chosen one was compact, widely supported, and effortless to operate. Its small footprint allowed it to be placed discreetly at the rear center of the vehicle, making it accessible regardless of which side the charging station cable originated from. The ease of operation mattered just as much as compatibility. A vehicle designed around eliminating waste should not introduce unnecessary friction at the point where it replenishes energy. This choice aligned perfectly with the philosophy that guided every other major decision: reduce effort, reduce complexity, reduce inefficiency. The difficulty some individuals face in categorizing the vehicle reveals an interesting truth about its nature. Traditional automotive labels, sedan, coupe, crossover, were built for shapes that evolved from the combustion engine era. This new platform does not neatly fit into any of those categories because its form is dictated by different priorities: low drag, minimum mass, energy optimization, and lower rolling resistance. Rather than trying to force it into a legacy definition, the more accurate perspective is to see it as a product occupying a new category defined by efficiency rather than tradition. Some may perceive that unfamiliarity as strange or intimidating, but others recognize it as a chance to rethink personal transportation from the ground up. A key enabler of that rethinking is solar energy. The integration of solar surfaces into the body is not symbolic. It provides a meaningful supplement to stored energy. Instead of treating sunshine as an afterthought, the platform uses it to reduce the frequency of plugging in. Drivers who live in sunny regions can collect enough energy each day to offset a significant portion of their driving needs. This shift in behavior, choosing a sunny parking spot rather than a shady one, allowing the vehicle to gather energy passively while stationary, reflects a broader transformation in how people interact with personal transportation. Instead of being something that must constantly draw power from the grid, the vehicle becomes a participant in the environment, gathering energy naturally as it sits. The maintenance considerations follow a similar pragmatic design. Although the three-wheel layout initially prompted experiments with different tire dimensions at the front and rear, the team eventually returned to a single size across all wheels to simplify servicing and ensure practical maintenance routines. Standardized tires make rotation predictable and reduce confusion for owners who expect familiarity, not novelty, in basic upkeep tasks. Efficiency shaped the early experiments, but usability shaped the final decision. The location of the charge port, placed centrally at the rear of the vehicle, grew out of a desire to keep interaction simple and consistent. Side-mounted ports in conventional vehicles often create moments of confusion at charging stations, depending on cable reach and charger layout. A central port avoids these complications entirely. Situations may arise where extensions or additional accessories make charging more convenient in certain environments, but the baseline design aims to eliminate the asymmetry and friction that many EV owners encounter. Beyond the immediate production model, the underlying design philosophy extends naturally into other potential vehicles. The platform's efficiency-first approach could be scaled for more passengers, expanded for cargo applications, or reduced for smaller mobility solutions. Concept sketches and design exercises explore what an efficient pickup, multi-seat transporter, or even a two-wheel platform might look like when built from the same ethos. But these explorations remain preliminary. The immediate priority is bringing the first vehicle to production and proving that efficiency at this scale can attract sustained demand and inspire confidence across both customers and investors. The investment landscape presents its own challenges. Traditional investors often evaluate products through the lens of existing automotive categories, and a two-seat ultra-efficient platform may appear limited when compared to mass-market sedans or trucks. But this perspective misses the point. The true value lies not in the number of seats, but in the breakthrough approach to energy usage, lightweight structures, solar integration, and composite methodologies. Once the platform is validated at scale, the value extends far beyond the first configuration. What appears small in one context becomes enormous when viewed as a foundation for many future vehicles and applications. Even the question of whether the vehicle should have a specific model name brought this philosophy into focus. The choice to forego an additional label stems from a belief in authenticity.
Some products are defined so strongly by their form and purpose that adding a name can actually dilute their identity. The design itself becomes the brand. The absence of a conventional badge or grille logo underscores that confidence and keeps the surface clean for functional purposes, reinforcing that the product exists because its shape achieves something meaningful, not because it needs ornamental decoration. Experiencing the vehicle in person often shifts perceptions dramatically. Photographs and videos flatten the form, exaggerating its uniqueness or unfamiliarity, but standing next to it reveals proportions that make intuitive sense, a footprint that is surprisingly practical, and an interior space that feels more inviting than expected. Many people who approach the vehicle armed with extensive research find their analytical questions fade once they sit inside or take a short ride. The experience itself becomes
the evolving relationship between the vehicle and its owners will inevitably reveal how energy-efficient mobility reshapes everyday decisions. People who previously sought shaded parking spaces to preserve interior temperature may find themselves doing the opposite, intentionally choosing open, sunny spots where the vehicle can gather as much solar energy as possible throughout the day. This simple behavioral reversal highlights how integrated solar generation can alter habits in surprising ways. Rather than treating energy as something purchased at a station, drivers begin to view it as something naturally accumulated whenever the vehicle rests under the sky. Over time, this mindset shift could lead to a more intuitive relationship with renewable power, where the connection between sunlight and mobility becomes as normal as charging a phone overnight. The deeper promise of such a design lies in how it reorients the way society thinks about transportation infrastructure. If enough vehicles generate a meaningful portion of their own energy, pressure on grid systems could decrease, especially during peak hours. Residential chargers might become supplementary rather than central. Neighborhoods where sunlight is abundant might see cumulative effects as more vehicles passively contribute to their own energy needs. The long-term implications extend beyond individuals into city planning, utility management, and renewable energy integration. Even small reductions in grid dependency, when scaled across thousands or millions of vehicles, can have measurable impacts on resource allocation. Beyond energy considerations, the design philosophy influences the emotional and psychological experiences of ownership. People often project their values onto the objects they use daily, and a vehicle shaped entirely around minimizing waste resonates with individuals who care deeply about efficiency, environmental responsibility, or simply clever engineering. The satisfaction of knowing that each mile traveled consumes far less energy than a conventional vehicle can provide a sense of alignment between personal choices and broader sustainability goals. For some, it may feel like driving a glimpse of the future, where mobility is not defined by excess, but by refinement and precision. The physical sensations offered by the platform differ from traditional vehicles. The combination of lightweight construction, advanced composites, and aerodynamic shaping produces a ride quality that feels smooth and unburdened, almost as if the vehicle slips through the air rather than pushing against it. This reduction in aerodynamic drag creates a distinct driving character, one that emphasizes glide rather than force. Drivers accustomed to heavier, boxy vehicles may find the experience surprisingly liberating, akin to transitioning from a bulky object to something engineered with elegant purpose. This sense of effortlessness can foster a stronger emotional bond between driver and machine, making the vehicle feel like a partner rather than a tool. The engineering challenges behind such a sensation require careful attention to structural integrity. Composite materials behave differently from steel or aluminum, especially under stress, vibration, and temperature changes. The goal is not merely to reduce mass, but to ensure that every surface and panel contributes to safety, rigidity, and longevity. Composite structures allow for organic shapes that support aerodynamic goals, but they also require a sophisticated understanding of how forces travel across the body. Engineers must constantly model potential stress points, evaluate impact zones, and validate that the vehicle meets stringent safety standards while preserving its lightweight advantage. Balancing these demands is a testament to the intricate coordination between design vision and engineering execution. Safety perceptions pose an interesting challenge. People sometimes equate unfamiliar shapes with lack of protection, even though safety is determined by structure, materials, and energy distribution rather than conformity to traditional forms. The aerodynamic profile is not a compromise on safety, but a means of optimizing airflow while ensuring strong crash performance through strategic reinforcement. The internal structure must handle front, side, and rollover scenarios. And because the vehicle uses a monocoque-like composite shell, the load paths differ from those of metal frame vehicles. The result is a form that appears unconventional, yet behaves predictably under stress, using controlled deformation to protect occupants. Perception plays a significant role in public acceptance, and much of that perception is shaped by familiarity. As more people see the vehicle on roads, initial uncertainty will likely give way to recognition and even admiration. Many groundbreaking designs in history experience similar journeys: aircraft that seemed impossibly shaped, buildings that challenged architectural norms, and technologies that felt ahead of their time. With repetition, what was once unusual becomes iconic. A future in which this design becomes a familiar part of streets and highways is entirely plausible. And that familiarity will strengthen the company's broader mission as more people witness the practicality and elegance of the concept. Another aspect of ongoing development involves ensuring a seamless experience between the physical vehicle and its digital ecosystem. Over-the-air updates can enhance efficiency, refine interface elements, improve driving dynamics, or introduce features requested by owners. The philosophy behind the software mirrors the philosophy behind the physical design: incremental improvement, responsiveness to real-world feedback, and relentless pursuit of optimization. This ensures that the ownership experience is not static, but evolves as technology advances and insights deepen. The ability to update a vehicle over time blurs the line between purchase and ongoing development, making the owner part of a continuous refinement process. Discussions about future models naturally emerge from curiosity about how the design language might evolve. While the current platform focuses on a lightweight two-passenger configuration, the underlying principles could be applied to many other form factors. Larger vehicles designed for families or cargo transport could adopt similar aerodynamic strategies, composite structures, and solar integration, though the exact shapes would require significant rethinking. Smaller vehicles for urban mobility or recreational use could emphasize agility, minimal energy consumption, and sleek simplicity. Even motorcycles or three-wheeled sport variants could emerge from the same design ethos, taking advantage of aerodynamic sculpting and lightweight engineering in novel ways. These possibilities expand the imagination, but remain secondary to the immediate priority of proving the foundation. As production nears, the company's internal culture increasingly revolves around discipline, clarity, and coordinated execution. Creativity continues, but within boundaries shaped by the finalized design. Engineering teams transition from exploration to validation. Supply chain specialists negotiate deadlines and quality assurances, and management aligns schedules with investment milestones. The shift from concept to manufacturing requires a mindset that balances ambition with realism. Every member of the team must maintain a clear understanding of what the product is, what it represents, and why consistency matters more than experimentation. The refinement of the assembly line includes attention to ergonomics for workers, ensuring that tasks are repeatable without causing fatigue or errors. Composite panels must be handled with care. Adhesives must cure under precise conditions. Wiring harnesses must route cleanly through narrow spaces, and alignment procedures must prevent even minor deviations that could affect aerodynamics. The efficiency philosophy extends into the manufacturing process itself. Waste reduction, streamlined motion, and intelligent sequencing are all part of the production ecosystem. One of the most compelling aspects of the platform's development is the confidence that comes from having reached a design-locked stage. While many startups still seek funding to create prototypes, this company has already completed the most complex engineering and design work. What remains is scaling, an endeavor challenging in its own right, but far more predictable than early-stage uncertainty. Investors often take comfort in this distinction, recognizing that the risks associated with theoretical engineering challenges have largely been resolved. The path ahead is about execution, logistics, and capital, not untested ideas. The emotional component of this stage is significant for the people working on the project. Years of imagining, sketching, simulating, modeling, and refining have culminated in a final form that is ready to be built in meaningful numbers. The pride that comes from seeing a concept become a manufacturable reality fuels motivation across teams. Yet the pressure is equally present. A design this unconventional invites scrutiny, and the responsibility of proving its value to the world weighs heavily on everyone involved. But that weight is balanced by enthusiasm, because the mission is not merely to sell vehicles, but to demonstrate that a fundamentally different approach to transportation can thrive in a world that desperately needs efficiency. As more people encounter the vehicle in real-world conditions, a collective shift in understanding will begin to take shape. Early adopters will likely become ambassadors without intending to, simply by driving something that behaves differently than typical vehicles. Observers will notice the quietness at low speeds, the absence of traditional engine noise, and the way the vehicle seems to glide with minimal effort. Conversations will naturally arise at charging stations, parking lots, or even
the solar integration further reinforces the shift toward intelligent design. When people see a surface that not only contributes structurally, but also generates meaningful energy, it challenges the assumption that a vehicle is simply a consumer of power. Instead, the idea that a vehicle can produce energy reframes it as an active participant in a personal ecosystem. Some owners may begin tracking their daily solar intake as casually as people now track their steps or calories burned. Others may discover that their weekly commutes require fewer grid charges than expected, creating a sense of independence that distinguishes this platform from conventional EVs. The psychological effect of knowing that the sun, an abundant, free resource, is powering part of one's mobility cannot be overstated. It changes the emotional narrative surrounding transportation from one of dependency to one of empowerment. As more real-world data becomes available, the software will increasingly personalize the ownership experience. Drivers who park in open areas might receive notifications estimating how many miles of free energy they collected in a given day. Those living in regions with intense sunlight will likely experience significantly greater solar benefits than those in cloudier climates. But even small contributions can add up over weeks and months. The relationship between climate, lifestyle, and mobility gradually becomes clearer, helping people make informed decisions about when and where to park, how often to charge, and how to plan long trips. The notion of long-distance travel itself transforms when operating in a vehicle so efficient that it uses roughly a quarter of the energy of conventional electric platforms. Road trips become less about locating frequent charging stops and more about enjoying the journey, knowing that each mile consumes a minimal amount of stored energy. Even during rest breaks or overnight stays, the vehicle continues to gather solar input, subtly extending range without any human intervention. Over multi-day journeys, this passive collection could meaningfully offset energy usage, especially in sunny conditions. The idea that a parked vehicle can meaningfully add miles while the driver sleeps introduces a new dimension of convenience and autonomy. Behind the scenes, engineers continue observing how environmental variables influence energy consumption. Wind speed, temperature, road surface, elevation changes, and tire pressure all affect efficiency. Because the platform is exceptionally sensitive to small changes, thanks to its low energy consumption baseline, engineers can study these variables with precision. Insights from such research may lead to software updates that help owners optimize their driving habits, tire maintenance routines, or even route choices. Efficiency becomes a shared pursuit between machine and driver, with each contributing to the outcome. The discussion around component repairability introduces another important dimension of long-term sustainability. Composite structures can be incredibly strong yet lightweight, but they require different repair approaches than traditional metal bodies. The challenge lies in ensuring that service centers have the expertise to fix damage effectively while maintaining structural integrity. Engineers must design panels and sections in ways that allow for modular replacement when possible, reducing waste and simplifying repairs. Achieving this balance reinforces the mission of using resources wisely not only during manufacturing, but throughout the vehicle's lifetime. The more the team works on refining the platform, the more they recognize the immense potential it holds for influencing industries beyond automobiles. Curved solar panels, lightweight composite architectures, and efficient electric drivetrains all have applications in fields such as architecture, marine transport, aviation, and decentralized energy storage. Buildings that incorporate lightweight solar surfaces could generate more power without bulky installations. Cargo drones or lightweight aircraft could benefit from aerodynamic surfaces backed by integrated solar generation. Remote communities might use composite solar structures to power essential services without relying heavily on grid infrastructure. Each of these possibilities stems from foundational breakthroughs demonstrated in the vehicle's design. The mission driving the project aligns not only with environmental considerations, but also with economic practicality. Reducing energy consumption directly decreases the cost of operation, making efficient vehicles appealing to individuals who value long-term affordability. Solar contribution further reduces expenses by offsetting electricity purchase needs. When vehicles demand less from the grid, utility companies can maintain lower infrastructure load, which can ultimately lead to economic benefits at the societal level. These cascading advantages demonstrate that efficiency is not merely a moral or ecological principle, it is a financially rational one. The interior experience plays a significant role in creating long-term attachment. Comfort is shaped not only by the shape of seats or the placement of controls, but also by the psychological atmosphere created through minimal distractions and optimized visibility. Because the aerodynamic form naturally influences interior proportions, designers must carefully consider how to maximize spaciousness within a compact footprint. Large glass surfaces, thoughtfully placed structural elements, and unobtrusive interfaces create an environment that feels open rather than constrained. The sense of being enveloped in a carefully sculpted space adds to the overall feeling that the vehicle was designed with purpose, precision, and respect for the occupant's needs. Driver engagement also evolves when the vehicle's physics encourage efficient behavior. Smooth acceleration, consistent speeds, and gentle braking naturally extend range. Owners may find themselves driving more thoughtfully, becoming aware of how subtle changes in behavior influence energy consumption. Over time, this heightened awareness can create a satisfying feedback loop, where the machine rewards efficient driving with greater range and smoother performance. This dynamic relationship fosters a sense of partnership between driver and vehicle. Even conversations around weight distribution and handling characteristics take on new meaning. Because the vehicle is significantly lighter than most modern EVs, its handling feels agile and responsive. The placement of battery modules, in-wheel motors, and composite structural supports ensures a low center of gravity and balanced performance. Drivers accustomed to heavier vehicles might be surprised by how intuitive and predictable the platform feels during turns, lane changes, or sudden maneuvers. Reduced weight also means reduced wear on tires and suspension components, contributing to lower long-term ownership costs. The experience of operating a vehicle engineered around minimal energy consumption introduces a subtle sense of harmony between purpose and execution. Each component has been selected or shaped with intention, avoiding unnecessary mass or complexity. This intentionality becomes evident to the driver over time. Instead of feeling like a collection of disparate parts assembled into a machine, the vehicle feels unified, coherent, and thoughtfully balanced. The aerodynamic exterior seamlessly transitions into a driving experience that reinforces the core idea that energy should not be wasted. Even minor details, such as how gently doors close or how smoothly power is delivered from the motors, contribute to the impression that the machine is optimized at a fundamental level. People who spend more time with the platform often find their perception of conventional vehicles shifting. After adjusting to a lightweight, efficiency-driven approach, the heft and drag of traditional cars become more apparent. The sensation of pushing a large, heavy structure through the air becomes noticeable, almost cumbersome by comparison. This contrast deepens appreciation for the principles guiding the new design, because once efficiency becomes
One particularly intriguing aspect of the platform's long-term evolution is its potential to integrate with broader energy ecosystems. As battery technology improves and renewable energy adoption increases, vehicles may eventually serve as both consumers and distributors of power. In such a scenario, an efficiency-first platform could play a significant role in stabilizing grid demands or supporting local renewable installations. If a vehicle consumes very little energy but can store meaningful amounts, it might serve as a buffer during peak hours or supply backup power during outages. This kind of integration would position the vehicle not merely as a mode of transportation, but as an active participant in energy management. The company's long-term vision also inspires interest in what future models might look like. While the initial platform focuses on a compact, ultra-efficient form, the underlying principles can be extended in multiple directions. A larger model could retain aerodynamic sophistication while accommodating more passengers or additional cargo. A smaller variant could emphasize agility and minimalism, perhaps targeting dense urban environments. Specialized versions could serve delivery fleets, recreational users, or emergency responders in remote regions. Each iteration would build on the foundation of efficiency, using lightweight materials, integrated solar surfaces, and aerodynamic optimization to achieve the highest possible performance with minimal waste. How these potential models evolve will depend not only on technical feasibility, but also on cultural acceptance. As people grow more comfortable with designs shaped by physics rather than tradition, the stigma associated with unconventional forms may fade, Vehicles optimized for efficiency could become aspirational symbols, admired for their clarity of purpose. The company may find that the audience for such designs expands far beyond early adopters, appealing to anyone who values long-term sustainability, technological sophistication, or the simple elegance of intelligent engineering. The production journey remains challenging but rewarding. Every step forward brings new insights and refinements. Engineers continually refine the bonding process to improve consistency and speed. Assembly technicians practice precise alignment techniques to ensure that panels meet seamlessly, reducing aerodynamic disturbances. Quality assurance teams perform exhaustive inspections to verify that each component meets stringent standards. Every subsystem, from seat mechanisms to cooling loops, undergoes repeated testing to confirm reliability. These processes reflect a commitment to building not only a functional product, but one that embodies excellence in every detail. The experience of test driving early prototypes reveals how much refinement has already occurred. Drivers comment on the stability during high-speed travel, the responsiveness of the in-wheel motors, and the quietness that defines the cabin environment. Engineers collect data from these drives to fine-tune steering ratios, suspension settings, and motor control algorithms. These iterative improvements gradually transform the prototype into a polished, production-ready machine capable of delivering a consistently enjoyable experience. Ownership of the vehicle gradually shapes a person's relationship with energy itself. When a driver becomes accustomed to traveling long distances on remarkably little energy, they gain a new appreciation for what conservation truly means. The consumption patterns of traditional vehicles begin to feel excessive in comparison. This shift in mindset can influence broader lifestyle choices, encouraging people to be more mindful of resource use in other areas of their lives as well. The vehicle becomes a catalyst for personal sustainability, reinforcing habits that extend beyond mobility. The significance of solar integration continues to reveal itself through real-world usage. For some owners, solar charging may cover the majority of their daily travels, effectively making short commutes energy neutral. For even those with longer distances, solar power can meaningfully reduce grid dependence. The knowledge that a portion of one's mobility is sourced directly from the sun fosters a uniquely positive emotional response. People feel connected to natural energy cycles, understanding that their transportation is supported not by extraction, but by abundance. This sense of harmony with the environment adds emotional richness to the ownership experience. Furthermore, the presence of solar panels on a vehicle challenges traditional notions of aesthetics. What once might have been viewed purely as a functional surface becomes an integral part of the visual identity. The panel's subtle texture and glossy finish reflect sunlight in dynamic ways, creating an interplay of reflections that change throughout the day. This combination of function and beauty illustrates that sustainability need not be hidden. It can be celebrated as a core element of design. As the company moves closer to delivering the first production units, the anticipation among supporters becomes palpable. Some individuals have followed the project from its earliest days, drawn by the promise of a radically efficient vehicle. Others discovered it later through online discussions, social media, or word of mouth. Regardless of when or how they learned about it, many share a deep excitement for what the platform represents. Their enthusiasm creates a sense of community among prospective owners, forming a network of individuals bonded by a shared belief in the value of efficiency. When deliveries begin, road visibility will exponentially increase public understanding. Seeing the vehicle in motion, quietly cutting through the air with minimal resistance, creates a powerful visual impression. The distinctive form stands out not because it seeks attention, but because it refuses to compromise on physics. Observers might find themselves drawn to the clarity of purpose in its lines, wondering why more vehicles are not shaped with similar intention.
Over time, these impressions might strengthen the broader movement toward efficiency-driven transportation. The company's engagement with early adopters will significantly influence the success of the launch. Responsive support, transparent communication, and attentive service can turn enthusiastic customers into lifelong ambassadors. Their real-world stories of range performance, solar gains, comfort, and reliability will guide the perceptions of those considering similar vehicles. The company understands the pivotal role these first customers play, and therefore works to ensure that their experience reflects the vision from which the vehicle was born. As the first wave of owners begin sharing their impressions, the broader public will gain a clearer sense of how the vehicle behaves outside controlled environments. Owners detailing their daily routines, how far they travel, how often they charge, how much solar energy they accumulate, and how the vehicle handles in traffic will provide the most authentic validation of the platform's promises. These first-hand reports hold a weight that no official advertisement or technical demonstration can match, because they reflect genuine experiences rather than curated narratives. People generally trust peer stories more than corporate statements, and in this context, such trust becomes a powerful catalyst for widespread acceptance. The vehicle's quiet operation will likely become one of the earliest talking points among new owners. The absence of engine noise means that subtle ambient sounds become more noticeable. Drivers might find themselves listening to their surroundings in ways they never did before, appreciating the quietness of early mornings or the gentle hum of tires rolling over pavement. Passengers, too, will feel the difference. Conversations are easier, music clarity improves, and long periods of silence become comfortable rather than awkward. This shift reshapes expectations, making the cabin feel more like a peaceful personal space than a simple transport tool. Drivers will quickly realize how predictable and consistent the vehicle feels under a variety of conditions. Its low drag profile translates into a remarkable steadiness at highway speeds, where many vehicles experience turbulence or shifting resistance. The shape cuts through headwinds with minimal effort, while side winds create less disturbance than expected given the lightweight structure. People accustomed to the weight-based stability of large sedans or trucks may be surprised that a lighter vehicle can feel equally planted when properly designed. This sensation reinforces the idea that efficiency and stability are not opposing qualities. They can coexist when engineering and aerodynamics are aligned. One of the quiet revolutions hidden within the platform is the reduced wear on brake components. Because regenerative braking plays such a large role in decelerating the vehicle, physical brake pads experience far less strain than in traditional cars. This not only reduces maintenance frequency, but also contributes to the broader theme of longevity. The mechanical simplicity made possible by in-wheel motors further reinforces this durability. With fewer moving parts, fewer points of failure, and less friction-based wear, the drivetrain becomes a long-lasting system requiring minimal intervention. Over years of ownership, these efficiencies translate into lower maintenance costs and fewer unexpected repair events. Drivers will also notice how the vehicle's telemetry provides more meaningful information compared to traditional dashboards. Rather than bombarding users with unnecessary metrics, the system highlights the data that truly matters.
In regions with sunny climates, the vehicle's solar contribution becomes part of everyday conversation. Owners track their solar gains almost the way fitness enthusiasts track steps. They compare notes about how different parking angles affect energy collection, how much charge they receive during seasonal changes, or how various weather patterns influence weekly totals. These conversations create a shared language centered around renewable mobility, bridging gaps between people who might otherwise never interact. The platform becomes not only a mode of transportation, but a catalyst for social engagement around sustainability. Meanwhile, the company's internal operations continue refining every detail related to production. Engineers optimize the curing process for composite bonding, ensuring uniform structural integrity across every unit. Manufacturing specialists fine-tune the assembly workflow to reduce wasted motion, minimize errors, and guarantee consistent output. Quality assurance teams develop sophisticated testing protocols to verify durability, alignment, electrical performance, and aerodynamic precision. Every step reflects a dedication to long-term reliability, recognizing that the platform must continue proving itself through real-world performance rather than theoretical promises. As production ramps up, early customers begin receiving updates about delivery timelines, customization options, and support resources. The excitement builds as people prepare for a type of ownership that departs significantly from anything they have experienced before. Families may discuss where the vehicle will be parked to maximize solar exposure, how it will fit into their daily routines, or what new possibilities it might unlock. Some may plan long-distance trips to test the efficiency firsthand. Others may simply look forward to the novelty of driving something that feels unmistakably different in both form and function. Upon delivery, driving the vehicle for the first time becomes a memorable experience. The sensation of near-silent acceleration, the lightness of the steering, and the ease with which the vehicle glides forward create a distinct impression that lingers long after the initial journey. The acceleration feels organic rather than aggressive, the motion fluid rather than abrupt. This harmony between machine and environment defines the emotional identity of the platform. Owners often reflect on this first experience as a moment when expectations were replaced by something more tangible and deeply satisfying. Over weeks and months of ownership, these impressions strengthen. People learn how the vehicle behaves on highways, in dense city streets, on rural roads, and in varying weather conditions. They notice how efficiently it climbs hills or how minimal the energy usage becomes when cruising at moderate speeds. As they gain familiarity, they adapt driving styles, sometimes consciously, sometimes unconsciously, to align with the platform's strengths. This natural adaptation enhances overall performance and deepens the driver's appreciation for the engineering principles behind the design. The effectiveness of solar integration becomes more apparent as time passes. During warmer months or in regions with strong sunlight, owners may find that their battery remains consistently topped up for local travel. Even those living in less sunny climates observe meaningful contributions over time, reducing the amount of charging needed. The psychological shift this creates cannot be overstated. A car that partially refuels itself becomes not only practical, but symbolically powerful. It changes